Hello everyone, how's it going? Dr. Spear here, and I'm ready to talk about our next topic here in Bio 101. And I'm going to start with just a little multiple choice question. So I'm going to post this to Canvas, and I want to collect that data. I want you guys to answer this next time you're on Canvas. But this is just to kind of stimulate the discussion, right? And so, simple question, why are you here? Meaning why are you at Murray State? Why are you getting a college education? And I've got several answers here. There are many good reasons to get a college education. There's no correct answer, all right? I'm just curious. So why am I curious about this, or why do I ask this question? I like to just know about our students. I like to know the general characteristics of our student body. I like to know your motivations. These things help me to design the course and helps me think about, like, you know, what I need to talk about and how I need to do things in class. But I really want to make you think about your motivations. And so that's kind of a lot of what we're going to talk about in this first part of the lecture here is I want you to think about, you know, how you learn and why you learn and what you know and where you get your information from. I think that's an important part of an education. And so this is just a technique to get you to start thinking about those things. Now, here at Murray State, you know, we provide a liberal arts education, which means that, you know, you're taking a lot of courses from a broad area of subjects. So think about your university studies classes versus the classes in your major, and you're taking all kinds of different classes. And we do that for a reason. If you look at your generation, and most of you in the next 10 years will have, on average, like 4 different jobs. This is called job churn. And this is, you know, a characteristic of the 21st century, is that most people are going to be jumping from job to job and career to career throughout their life. Many of these jobs that your generation is going to have don't even exist yet. And so you can't really prepare for a specific job, especially if it doesn't exist. What we want to do is we want to prepare you for flexible. We want you to be flexible. A broad-based education allows you to be flexible and allows you to adapt to changing circumstances. And so that's an important reason why we give you this liberal arts education. And certainly that's an important reason why you're getting a college degree, you know, because it's going to help you with your future employment. Me personally, I think that's an important reason. I don't think it's the most important reason, right? I think your intellectual growth is the most important reason. I just think that learning is fascinating. Everyone should be learning their whole lifetime, and that's good for you, but that also makes you a better citizen, which makes it good for me. And in a democracy, the more education people have, the more education citizens have, the better off we all are. Of course, we're preparing you for the job market as well. So there's all kinds of good things that come out of a college education. But I want you to think about, you know, what is it that motivates you and why are you here? Because, you know, these ideas are going to shape the rest of your life. Now, public education is something that traditionally has been considered a public good. Like I said, we all do better the more education we all have. That's why we have public education. But, you know, lately there's been a shift. And there's a lot of people that kind of think of college education as a commodity, not a public good. And so it's something to be bought and sold. And so when you think of education in that way, you think, well, you know, the primary beneficiary of this education is the student, so they should pay for it. And so, you know, college is getting more and more expensive and harder to afford. And I don't think that that's necessarily a good idea. That's not a good long-term solution for the country. The country's better off, And we all benefit from each other's education. And so I think of education more like a public good. And, that's just the tensions that we feel in college education these days and secondary education these days. But these are all important reasons why you should be getting an education. And since you're getting an education, you need to start thinking more about your motivations and why are you here and what's the point of all this. And so this sort of self-reflection, I think, is good for everyone. And we try to encourage it. And not just things like, why am I here? Why am I on this planet? Why am I at Murray State? But like, what kind of person do I want to be? Like things like, how do I learn? What techniques work best for me when I'm studying? This is all good for you to constantly think about to see if you can improve and improve yourself. And a question that you'll hear me ask quite a bit, and that's central to today's theme, is why do I believe what I believe? And so we all have lots of beliefs about many different things. But I want to ask you to start thinking about, well, why do I believe the things I believe? Where did I get that information from? I think that's an important part of your education. And so there's all kinds of beliefs out there. These are just some examples, right? Do you believe that all living things evolved from earlier forms of life? Do you believe that vaccines give you autism? Do you believe that your soul goes to heaven when you die? Do you believe that Bill Gates is using the COVID crisis to implant microchips into your brain? These are all beliefs that are out there. Some of you might believe some of them and some of you might not. But what I want you to start thinking about is, why do you believe what you believe? So no matter what your belief is on any of these broad topics, think about where that came from. And again, the source of your information and where do we get our information, that's kind of central to the theme of this lecture. And so education, in my opinion, is not just gathering information. Certainly that's important. Certainly it's important to pick up pieces of information that you didn't have before. But, we live in the information age now. Like, the sum total of humanity's knowledge is at your fingertips. I mean, you're walking around with it in your pocket. You can pull out your phone and find out any information. And so what you really need is to be able to evaluate the quality of the source of information. And so when you think about why do you believe something, or where did that information come from, then you start to think about different sources of knowledge. And some sources of knowledge are good for some questions, and other sources of knowledge are good for other questions. And so thinking about these things is important. And thinking about thinking is kind of what we call critical thinking. And again, this is something that we try to emphasize here at Murray State, is we want you to develop your critical thinking skills, thinking about your thinking, and why do you believe the things that you believe. And there are all kinds of different sources of information. Science, religion, art, philosophy, personal experience, culture. There's many different sources of knowledge. And we're not going to argue that one is better than the other in general. And we're not going to say that you should only you adhere to one source of information. That doesn't make any sense. We all use different sources of information. And we just need to understand what makes those sources different. And then, what sorts of questions are appropriate for what types of knowledge. And so that's where we're heading with this whole discussion. And so, you can look at things like science. This is a science class, so we're going to talk mostly about science. And science is good for answering questions like, do you believe that all living things evolved from earlier forms of life? Do you believe that vaccines give you autism? Science can help you very much answer that question. But, What happens to your soul when you die? Science is not very good at answering that question. But these are all important questions. And there's plenty of room in your brain for all these different sources of information. You don't have to, lock on to a single source of information and ignore all the others. That doesn't make any sense. What you need to do is to understand what makes these different sources different. So, of course, this is a science class. And so we're going to talk mostly about questions that are best answered by the scientific method. And so that's one of the things we need to talk about. What kinds of questions do we answer with the scientific method? And what kinds of questions are not appropriate for science? And what is science? And so since, this rest of this semester is all going to be talking about scientific information, it's important that we understand what makes science different from other sources of knowledge. And so here's another quick quiz. Which one of these is a scientist? Well, the correct answer is C. This is one of my former grad students, and he's out measuring fish and collecting data, and he's very much a scientist. I bring this up because we have this common idea, of a scientist as someone who wears a lab coat and who has looking at a test tube like an A, or like holding a beaker like Professor Frank is in letter B. And those definitely are characteristics of some scientists, but there's lots of different kinds of science, and there's lots of different kinds of scientists out there. And so we need to move beyond our common, the sort of stereotypical idea of what is science. And so let's talk about the scientific method and what makes it different. And so we're going to talk about what is science, we'll talk about the scientific method, and then we're going to talk about science in practice. So science is a process. It's a way of gaining information. It's a process for trying to understand things in the natural world. And so we often think of scientists, again, or a science class as somewhere where you're learning lots of facts. It's important to learn scientific information, but science is much more than that. Science is a way of gathering new information, and it's a way of trying to understand the natural world. The scientific process includes making observations, forming hypotheses, and then testing them. And so we're trying to answer questions using natural phenomena, not supernatural. And so, someone might explain the diversity of life on Earth as all life on Earth was created by a supreme being a few thousand years ago and created just as it is. That might be true. That might be exactly how it happened. But that's not a scientific explanation because it relies upon the supernatural. Scientists must restrict themselves to explaining things using natural phenomena. And science is all about asking questions about natural phenomena and trying to understand the natural world. That doesn't mean that supernatural things are unimportant. It just means they're not in the province of science. And so we need to test our hypotheses, which means we need to gather evidence. And so we're going to gather evidence to try to support our ideas, and that evidence must be based in the natural world. And so science is not just memorizing a bunch of facts. And again, that's kind of the common thought when you take a science class. And certainly there's lots of information that we're going to learn, but I want to help you understand that science is about the process of learning, of gathering that information, of creating that new knowledge. Some people think science is a search for truth, but most scientists would disagree with that. I would disagree with that. Science is not a search for truth. That's something like a philosopher. What is truth? How do we find truth? What is true? What is false? Science is not trying to find what is truth. Science is just trying to understand the natural world. That's it. It's nothing more than that. And so when we talk about applying different forms of knowledge to different types of questions, here is a very clear indicator of where science is appropriate. Science is about understanding the natural world, and that's it. It's not appropriate to apply to other things. So here's a quote from Marcia McNutt, who was president of the National Academy of Sciences. This is her definition of science. Science is not a body of facts. Science is a method for deciding whether what we choose to believe has a basis in the laws of nature or not. And so there's that idea again. Why do you believe what you believe? You have all kinds of beliefs in your head, and where did you get those beliefs from? Science is just a way of saying, does this belief follow the laws of nature or not? That's all it is. And it's much more than just memorizing all the bones in the body or something like that. It's a way of doing things. It's a process. It's a method. But it's only one of many disciplines. And it's a process for understanding the physical world, but it's not the only thing important to humans. And so this is something else that I think it's important to point out. There are other sources of knowledge, like religion and philosophy and art and ethics and culture. And they're all also valid sources of knowledge. They also ask important questions. It's just that they ask questions that are outside the province of science. Now, there are a lot of people who would like to, there's lots of people who like to stir up stuff these days, right? There's lots of people that try to get you aggravated. And there's lots of people that think that you can't, you can only have one source of knowledge. If you believe in science, then you must reject religion, or if you're religious, you must reject science. And I don't believe that, and most scientists don't believe that. Your brain is big enough to hold all these different ideas in your head. There's lots of important questions, and there's lots of useful ways to answer those questions, and there's lots of different sources of knowledge, and that's okay. That's a good thing. We just need to understand what makes other sources of knowledge different from science. So being a scientist does not imply that you must ignore your religion or your philosophy or your politics or whatever. It's okay to have all of those ideas, and your brain is big enough to hold them all. So don't listen to people when they try to, to divide you and try to exclude certain things. But you do need to understand how these processes work. Since it's a science class, you do need to understand how science works. And you do need to understand when science is appropriate. And, let's not kid ourselves. I think that science is the best way to understand the natural world. You can use other sources of knowledge to try to understand the natural world, but I don't think they're as good as science. That doesn't invalidate them. It just means they're appropriate for certain questions, and science is appropriate for questions about natural phenomena. So this is a science class. And so we're going to discuss science and the scientific method and what kinds of questions are best answered through science. It's up to you to decide how science fits into your personal belief system. And so I can't tell you what to believe, but again, I can ask you to question, why do I believe what I believe? What is my source of knowledge on this? And then you have to decide what makes the most sense for you. And so you need to, ask yourself, when does science provide useful answers? Why should you believe what scientists say? I think that once you understand the scientific method, you understand it's a rigorous process, and it gives trustworthy information if it's applied appropriately. Why do scientists sometimes contradict one another? We see this sometimes. One study shows something and one study shows another result. Well, if you understand the scientific method, you can put that in context and you can understand why that happens. Why does our understanding of the natural world change? Again, if you understand the scientific method, you can see that that's part of the process. The scientific method is all about throwing out old ideas and coming up with new, better ideas. And so our understanding of the world does change. That's part of the process. Why do we not have a good understanding of some things in the natural world? Why don't we understand some situations? Well, again, if you understand the scientific method, you can put all that into context. The analogy here is that I'm not expecting you to become a scientist, right? You might think that other sources of knowledge are more important to you. That's fine, right? But the analogy here is like, if this was a class on Greek mythology, I wouldn't expect you to believe the Greek myths, but I would expect you to understand them because that's part of the class. And so I'm not going to expect you to become a scientist, but I am going to expect you to understand the scientific method because this is a science class. And then you're going to have to decide, what makes the most sense to you. And so we can talk about different kinds of questions that are appropriate for the scientific method. And so, for example, should Obamacare cover birth control pills? Well, that's not really a good question to answer with the scientific method. That's not really about the natural world. That's a value judgment. That's an ethical decision or a moral decision. Although that is something that takes place in the natural world, it's not about understanding how the natural world works. And so that would not be a good question to answer with the scientific. You would need other sources of knowledge. Does the MMR vaccine lead to higher rates of autism? Well, now that is a good scientific question. That does have to do with how the natural world works and understanding natural phenomena. And we'll talk about this particular example. But there are lots of people who believe that vaccine causes autism. But the majority of scientists, the vast majority of scientists, do not believe that. And again, because of the scientific method, it suggests that there is no link between those two. And so that's, again, a good question that is well answered by the scientific method. And we'll talk about those details when we talk about that a little bit later. Are there other forms of life outside our galaxy? Again, you might think, well, that's kind of science fiction. That's not really something that you can answer with science. But, the natural world doesn't mean our world, our planet. It means the physical universe. And, if there's life outside of our universe or outside of our galaxy, that definitely is a kind of question that science could try and answer. And the scientific method would be appropriate. Did life on Earth begin as simple one-celled organisms and slowly evolve into modern organisms? And some people might say, well, that if that happened a long time ago, there's no way you could test it, and there's no way you could ever actually figure this out, so it can't be scientific. And that's not true. That it is a very good scientific question. And there are hypotheses about how modern organisms arose from earlier ones, and they are testable, and the vast majority of evidence, all the evidence suggests that the scientific consensus of all the evidence suggests that yes, modern organisms did evolve from earlier forms of life. That's the scientific explanation for the life that we see. There are other explanations, which might be right, but this is a science class, and we're going to deal with natural phenomena. And the scientific answer for life's diversity is that it all arose from earlier, more simple forms of life. So let's talk about the scientific method in a little bit of detail. And so it's not as clean a process as what's outlined here, but this helps us to kind of organize our thinking about the scientific method. Basically, we make an observation, we form a question, we create a hypothesis about an answer to the question, then we test that hypothesis. We run experiments, we collect data, we make observations. If the data support the hypothesis, great. Can we do it again? Repeatability is very important in the scientific method. And what new questions do you have now that your original hypothesis is supported. If the data don't support the hypothesis, then you reject it, and you come up with a new hypothesis, and you test that new hypothesis. And then you repeat, and repeat, and repeat. And so, again, repeatability is very important to the scientific method, but we're always coming up with new questions that need new data collection. We're always challenging existing hypotheses to see if we can come up with better explanations. And so it's a constant process of trying to answer questions, collecting data, then asking new questions. And so here's a figure from your book that kind of reiterates what I just said. So when you read the chapter, kind of go through this, and it kind of talks about those steps and gives you examples of those steps, just like I talked about. Like I said, it's constantly repeating, and we're constantly challenging existing thinking. And so we like to say that all answers in science are tentative based on the current data. And so we have, an answer, we have an understanding of some natural phenomenon based upon what we've already studied. But if we get new data that contradicts our understanding, we can change our mind. And that's an important part of the scientific method that does set it apart from other sources of knowledge. And so this is one of my favorite sayings: science gives contingent knowledge, not absolute knowledge. And so it's a source of knowledge, and what we know in science today is contingent upon what we've studied so far. But it's not absolute. Scientists never claim to have the absolute answer, and that this is the absolute truth, and it should not be questioned anymore, right? Other sources of knowledge do claim to know the absolute truth, but not science. Scientific knowledge is always contingent upon the data that are collected, but we can always change our mind. And so that's an important characteristic of science. And so you see how this is a process. So science is more than just memorizing facts. It's a way of coming up with new information. And it's not foolproof. It's a human endeavor. So it's not foolproof, but it is self-correcting. And that also is an important characteristic of science, that we're willing to change our mind, and that we're constantly challenging existing ideas. And hopefully, over time, we get rid of bad ideas, and the only thing that's left are good ideas. And that's an important part of the process. This is another one of my favorite sayings. Science is designed to efficiently weed out bad ideas. And so that's the method to the madness here. That's why we constantly challenge hypotheses, and we're constantly testing hypotheses. And the idea is we're trying to weed out bad ideas. Bad ideas, over the long run, will not be well supported by the evidence, and they will disappear. So we mentioned about hypotheses. We're going to talk about hypotheses quite a bit. Let's talk about them briefly now, and we'll talk about them in more detail in an upcoming lecture. So what is a hypothesis? There's lots of definitions. This is a good definition. It's a tentative answer to a well-framed question. And so you can have any kind of hypothesis, right, based on any kind of knowledge. But scientific hypotheses have some unique characteristics. They are falsifiable, and they lead to predictions which can be tested by observations or experimentation using natural phenomena. And so now I've underlined all the very important words in this definition here. And so when we talk about hypotheses in the future lecture, we're going to talk about what's it mean to be falsifiable and what's it mean to be testable. But you see that we've got specific things that sort of identify a scientific hypothesis. And it's important that you can make predictions and that you can test those predictions. But to be able to test them, you can only use natural phenomena. That's really the only way to test anything. And so those are the important characteristics of a scientific hypothesis. Okay, so now one thing that I'd like to point out is that every one of you uses the scientific method. You might not realize it, but every one of you is confronted with things every day, and you use a process to try to figure out what's going on in the natural world. And so let me give you an example, simple example. You've got a flashlight that doesn't work. That's what you observe. And so it leads to a question. Well, why didn't this flashlight work? And so you come up with several ideas to try to explain why the flashlight doesn't work. And so maybe high humidity is causing the flashlight to malfunction. Maybe the batteries are dead. Maybe your flashlight hates you. Maybe the bulb is burned out. And so you've all done this in one way or another, where you've had something and you've had to come up with different possible explanations, and then you try to figure out which is the best explanation. You try to collect data to decide which is the best explanation. And if your data don't support an explanation, you throw out that explanation. Well, that's just the scientific method, right? And so we can look at each of these and try and decide, which of these ideas are scientific and which ones aren't. So And so this diagram is kind of showing, you observe the flashlight's out, you ask yourself, look at her, she asks yourself, why is my flashlight not working? And she's got a couple of hypotheses. One's dead batteries, one's the bulb is burned out. And so you can make predictions from those hypotheses and then test those predictions. And so the prediction from hypothesis 1 is that if I replace the batteries, then the flashlight will work. And so that's what she does. She replaces the batteries and she tests the flashlight, and it doesn't work. And so that hypothesis has been falsified. So you made a prediction, but the prediction did not come true. And so we reject that hypothesis. It wasn't the batteries. Hypothesis 2 makes the prediction that, well, if the bulb's burnt out, if I replace the bulb, then the flashlight should work. So to test that prediction, she replaces the bulb, and the flashlight works. So that test did not falsify her hypothesis. And so this is a good example of a simple way that you would use the scientific method in everyday life. It's the same idea. It's something that you've done. And so you should be able to understand it, that way. So now, failure to falsify a hypothesis does not prove that hypothesis. And we'll talk about that word prove in future lectures. And we don't like that word prove very much in science. So for example, when she changed out the bulb, that made the flashlight work. And so she made a prediction, the prediction came true. And so that, she was not able to falsify that hypothesis. It's entirely likely that bulb was burned out. But it doesn't prove that the bulb was burned out. Right? It's possible that the first bulb was just inserted incorrectly. And that's why the flashlight didn't work. And when you put the new bulb in, you inserted that bulb correctly, And so that's why the flashlight started working. And so it's important to keep these sort of this sort of logic in mind when you're trying to evaluate hypotheses, right? So failure to falsify a hypothesis doesn't prove the hypothesis, but it does support the hypothesis. And so, again, in science, we never prove anything, but we can disprove things. And when we talk about a hypothesis being falsifiable, we're talking about the ability to disprove it. And so here we failed to disprove the hypothesis, but we did not prove that the bulb was burned out. And we never talk about proving anything in science. We just fail to disprove. And that might sound like lawyer talk. That might sound like I'm being pedantic with the language, but it is really important. When you talk about the philosophy of science, and you talk about the philosophy of anything, you got to choose your words carefully. We need to be precise with our language. And so, pay attention to this sort of language as you go through the chapter and as we go through this lecture. If you fail to disprove a hypothesis, you're cautiously confident that you have the correct answer, right? You're not completely confident, but you feel that you have some support. You have some support for a correct answer. But again, in science, if you get new data that contradicts that hypothesis, that does disprove the hypothesis, then you throw the hypothesis out. And that's why scientific knowledge is, gives contingent, science gives contingent knowledge, not absolute knowledge. And so scientists have kind of a cautious language, and we talk in terms of probabilities or likelihoods. And so again, we don't talk about absolutes. And so science doesn't provide certainties. We talk about probability. Something's highly probable or something's highly likely. But we can always change our mind if we get new, better data. And so that goes back to something we talked about earlier. Like, why does it seem like scientists contradict each other? And, they could be looking at different sources of data. Or, that's part of the process, is looking at different sources of data and trying to decide who's got the better idea, which result is more likely, or which answer is more probable. Right? But we don't have certainties, and so that's why there's that argument. That's why, our understanding of the world changes, is because science is all about changing your mind if you get better evidence, if you get better data. And that's different than other sources of knowledge. Okay, so that's our introduction into the scientific method. And so we're going to talk in more detail about that in the next couple of lectures. But again, what I'm hoping for you to understand is, I'm hoping that you understand that science is different than other sources of knowledge, but that doesn't mean that it's the only source of knowledge or the best. I think it's the best for understanding the natural world, but there are lots of other important questions that science cannot answer. And an educated person and a well-rounded person takes into account all these different sources of knowledge, and you have to figure out, what fits into your belief system, and why do you believe what you believe, and does what you believe, is it supported by our understanding of the laws of nature? That's what science can tell you. So yeah, good stuff. That's all I have right now, but I'll see you in the next lecture. So take it easy. Later.